University and the management of Dr. MGR Educational and Research Institute, deemed university, I take this proud privilege to welcome our guest speaker, Ashutosh Tiwari from the Space Center. And thank you, Ms. Suganti from Temtech, for including us in this program. We are very happy to be a part of this program, and uh, we take this opportunity to thank every participant who has enrolled in this program, and we uh, are very happy that we are able to give an insight into the space emerging technologies in space sector. And Thank you so much, Suganti, again, once again, from all of us from the uh, team, and especially my special thanks from Dr. Malini Pandey, who's our joint registrar, and she is also the director of the Academic Staff College, and Dean Dr. Gomati, who's also not present today, but then they send their wishes and congratulations on this new endeavor. And I take this again and my opportunity to wish Ashutosh Tiwari on his mission on the giving us the insight into the space program. I hope all our participants, both on the faculty side and the student side, would be able to uh, bring into the beautiful technology and emerging technology, and get themselves educated. And thank you very much. And we wish you all the best in all your future endeavor. Thank you.
Thank you, ma'am.
Yeah, okay. So thank you, ma'am. So before we start Mr. Ashish Kumar's session, I would like to give some short introduction about him. So Mr. Ashish Kumar Mishra, hailing from Palasur, Odisha, in India, is a celebrated figure in the realm of the space science and engineering. With the precious affiliations to the URAO Satellite Center at the Indian Space Research Organization, located in Bangalore, India. And Mr. Ra's educational journey led him to earn a Bachelor of Technology in Electronics and Communication Engineering from the Indian Institute of Space Science and Technology in Thiruvananthapuram, India. So his professional path has seen him specialized in satellite technology and space exploration, so particularly focusing on the satellite control systems. Moreover, Mishra has adaptively integrated cutting-edge technologies such as artificial intelligence and machine learning and deep learning into the space missions, showcasing his innovative approach to solving the complex challenges in space exploration. And his scholarly contributions include the numerous research papers in esteemed journals and conferences, highlighting his academic prose and commitment to advancing the space technology. And his accolades, including awards at state and national level, won years, the District Young Dignitary Award, and recognition as a Kishore Vaignanik as a Protections Yojana scholar. Beyond his professional achievements, Mishra is passionate about the technology in the space sector, actively engaging in research and development to enhance the satellite's capabilities, and evident in missions like Chandrayaan 3 and Aditya L1. His vision and dedication to pushing the boundaries of space exploration make him an inspiring the figure and a key contributor to the scientific community efforts to unravel the mysteries of the universe. At the end, I would like to introduce to the motto of Mr. Ashish Kumar, is advancing the frontiers of space exploration through the innovation and collaboration with a steadfast commitment to leverage the cutting edge technologies for the betterment of humankind. So I would like to hand over the session to Mr. Ashish Kumar, and also thanks a lot for joining us today, and over to you, sir.
Yeah. Thank you, everyone, and good morning. So actually, I'm really thankful to Thames Tech Solution for like providing me with this opportunity to present to you all guys. Um, Hope I'll be clear and I'll be able to kindle your interest in this space sector. So I'll just start by playing a clip from Star Trek. This is like space warfare. This is what is coming future. Hope everyone is ready for.
Sir, please increase the volume.
Yeah, yeah, sure.
Yeah.
Yeah, it's in full volume though. Actually, the screen sharing option is like to screen directly. Sorry, you don't have it there. Because of that, it's
But we could not hear the sound.
okay. Fine, fine. Then I'll just skip this one. Then, right.
Yeah.
Anyways, clip is just like to demonstrate. Yeah. So what I showed last slide, it was like space warfare. So uh, people might like you people might realize that space is like the new frontier now. Whatever progress you are having in country is somehow related to space. Like even if you just give someone a phone call or you just go to ATM and like withdraw some cash, everything is related to space. Like the ATM machine, it communicates with the satellite communicates with the bank, and further this to and fro communication happens, and you're able to withdraw the cash. So any development which you're able to see in countries like directly or indirectly related to space. So if any country or if any nation tries to destroy your satellite, that like directly it will affect your economy and your development and all. So your satellite is like your national treasure. So what I saw in that space like Star Trek episode is how it might be in future. Like instead of directly attacking a country, they will attack your satellites and then they will make you weak, and then after that, once you're weak, they will attack you directly. So that is how it is supposed to be, maybe 30, 40 years from now. So this is the outline of my presentation. Ma'am, so are you able to see my slide properly?
Yeah, yes, sir.
Okay. So you can see the meme on right hand side. So yesterday it was a wild sleep day. So I hope everyone is awake by now. I hope you will be awake throughout the session, and it make it like wild awake day or something. Okay. So I'll be covering the present scenario, which is there currently, which all the space nations are like facing, which what India is facing right now, and how is the environment right now for space sector. Then I'll go to what all problems we are facing right now, and what possible solutions are there for those problems. What are the emerging technologies which are there in space sector, and you might be like encountering those technologies in your next maybe 5 to 10 years of your journey. What I heard from ma'am is like many of you are like space enthusiasts. So some of you might get into ISRO, and you might be directly handling those technologies, emerging technologies, which I will cover right now, like in my lecture. And then I'll cover what is your role and what is the role of public in ISRO. And then finally, I'll cover like how do you join ISRO and how do you collaborate with us. And lastly, I'll just cover questions and answers. So this is actually the scenario to some extent. So ISRO, as you know, last year around August 23, Chandrayaan 3 landed on the moon. So we are really happy. Whole country was enjoying with us, and like I personally, me on behalf of my team, actually thank all the public and the whoever has supported and prayed for us. It was really a tough journey particularly after the failure of Chandrayaan 2, and Chandrayaan 3. Success of that was really sweet. for us. But anyway, after we succeed, we now see that there are a lot of other missions which are pending. It's not like we didn't know that other missions are there, but still there is lot of steps to climb, and like we need to go really far ahead from this point. So this is just the starting of the space journey in India. So, so what is the situation right now? Like, space sector is progressing very fast, and Indian space sector is actually ruling the market because we are able to launch satellites at a cheaper in a cheaper way, in an efficient way. Other space nations which are currently there, like Japan and US, ESA, like European Space Agency, China, um, all these countries, they do have their own space setup and they are probably advanced than us. But in terms of cost, ISRO is best till now. Like it tries to uh, we try to launch any satellite by less than 10 times the cost of what the other nations are trying to launch it with. So that is like whoever is providing the best type of facility and best like profit and all, they will only rule the market. So Indian space sector is like currently, like if you see that scenario, Indian space sector is really good in a good position to rule the market. Now one more thing is like advanced space technologies, whatever is there. So there is some decent progress in ISRO, as well as there are some private companies also, private space startups also, which have made some decent progress in that area. So and one more thing is like we have a lot of advancement to develop, and there are a lot of new technologies which we need to develop. And so you're like in a really good position, like you are not starting from scratch, neither you are not in a position like you are saturated somewhere. So you are in really in between, where you have a lot to do and you have technologies in your hand and which are supporting you from the back. So this is a really nice time to enter the space sector. Then new field of interest for engineering and science domains, they have arrived because of space exploration. Like once you are able to land on moon or say land on Mars, or you are able to establish any space station, there are a lot of experiments and lot of scientific interest can be found from there. And then government as well as public supports ISRO and all the space sector. So that way also you are having a lot of advantages. And then very few players are there in the market. So what I earlier said, like only 4 to 5 countries are there which are really in the play, and other countries are actually dependent on us um, for satellite, for the launch of their satellite, or for any type of communication which they want to do with based on like space communications. So that way you are in a really nice position actually to enter into space sector right now. So you can see as I said, like satellite is a very important uh, treasure of the nation. So you can see all the uses I have highlighted: broadcasting, communication, disaster rescue, and then tracking, and then emergency, maritime affairs. You might have heard about Navig satellites. You might have heard about Astrosat satellites, Microsat, Insat. All these are like for all these satellites serve different purposes for our nation. So once you protect your satellite, then only you will be able to protect a job. Imagine how many number of jobs that are associated with all these different trades or different domains. All of them will become jobless if you are not able to protect your satellite right now. So that is a real scenario right now. You are like you are dealing with something which is of very high security, and basically that is your treasure. That's it. And then today in space, like the space industry, it's like a part of big game involving thousands of crores of rupees. Like if some country wants to launch their satellite, they will offer maybe like in 500, 600 crores worth of money. They will give to any, like say ISRO or say any other private agency or anything. So it involves like lot of money. So it's a big game, so naturally it will interest everyone, all the private investors. And secondly, like till 2020, only ISRO was permitted to carry out the space activities. Nowadays, all the private industries have been permitted also. And recently, I think our Prime Minister, he declared that foreign direct investment is also permitted to be like foreign investors can directly invest now in India satellite systems and launch vehicles and everything, space related everything sectors they can invest. So this is a really this is a boost to like space industry in India. Then in 2023 alone, I have written like 54 new space startups have been launched out of the total of 204 over the period of from 2018, maybe say 2018 to 2022. Earlier, they used to like end-to-end space activity were not there, but they used to like build some parts and some parts of satellites, some parts of rocket like that. So nowadays they can carry end to end. But this like last year itself, 54 new space startups were launched, and out of like total 380.25 million funding, only 123.9 million funding was received last year itself for the space startups. And then so this is the current situation which is there, and India is like one step ahead of all the other space agency in terms of these numbers. India being the high, like really large democratic country, it has got a lot of like investment. It has got a lot of startups. Then there is a like huge population to support those startups, like in terms of manpower needs. All of these contribute to like a really nice time for you to go into space. So that being said, let me go to the hurdles or challenges that are ahead of us, and what we are facing. How can we first, if you want to solve anything, you need to first list down the hurdles. You need to identify the challenges, or you need to identify those problems which you are facing. So this is what I've done for you. So to understand, to appreciate those future emerging technologies, what is the need of those technologies, and how it is important for us. Um, I have listed down the challenges. So first thing is like only less than 1% of the universe has been explored. Universe till now, what we know is like never ending. We didn't even discover the full part of the universe. Like full universe is not yet discovered, and it's expanding. It keeps on expanding, and like we don't know how big it is. So maybe probably less than 1% is a 1% actually is a big number. So probably 0.01% or something, maybe less than that, has been only explored till now. And then all the as you know, there are a lot of theories out there which claim that our origin is through space. Life is originated through space. There are some other couple of theories also which suggest like life originated from ocean, deep oceans and all. But if you one of the possibilities through space. So if you see, if you want to know your origin, and if you want to know what exactly happened um, during the formation of Earth, or what exactly happened during the Big Bang theory and all. So you need to understand the science behind the working of the universe. So for that, you need to explore the universe. So if you are exploring only 0.01% of the universe, that is not justice done to science, or to any theory which is based out of that science. Our main objective is like explore as much of universe as possible to understand it, and to understand our origin out of that. And limited access to advanced technology. We don't have that pretty advanced technology. We what we have is like mediocre type of technology. It's currently it's advancing, but still there is because the space. Usually space are like very secretive, sensitive data and very confidential data. So it's very difficult to get hold of the very advanced technology. So kind of we are in the developing phase. It is slowly progress, but still there is a limited access. And then limited funds are allocated only out of maybe last year 0.04% of the GDP was allocated to space compared to Indian like space other US maybe it was like 0.28%, like 7 times the fund which is received direct, like 7 times in thousand percentage the direct like amount may be pretty much higher. So that way you are dealing with limited funds. So you have to limit your cost. You need to have a trade-off between the equipment which you can use and the cost of those equipments. Then what I said just now, the data is very sensitive and confidential. Countries are hesitant to share their data, and countries they don't like to give access to any of their technologies. And a lot of expertise and manpower is required for satellite operation ground support. If the satellite is a whole system, so it requires expertise from all of the domains, starting from in electronics engineer, mechanical engineer, to a biologist. Even a biologist is required for satellite, like in terms of Gaganyaan mission and all. There, that human environment, how it is like needs to be set up, and what kind of uh, like human body, what kind of problems it might face, and then how do you diagnose for something, like all kind of expertise is required for this space. Like it's a system in together. So, and that being said, there is a huge manpower behind all the satellite which monitors each and every aspect of the satellite. So that is also like contributing to the funds, like along with that the limited funds allocated is like a really hard challenge for us to progress in this field. And then space pollution and space debris, you need to take care of that also, because as you know, like there has been several anti-missile tests before like in the last century, and sorry, in the last decade, and because of that there has been a lot of very fine pellets kind of thing, like in the Leo orbit, I think just above the Leo orbit there is some 2 lakhs like small pieces of debris around maybe point I forgot the exact number, like some centimeter, like tens of centimeter dimension. Those are revolving around with a very high speed. So it like if any satellite just happens to pass, and somehow the debris like collides with the satellite is damaged, and it cannot be, like the mission has failed, and it cannot be you cannot proceed with that mission for the next whatever planning you had for in mind. So that is really important for us. Like we don't want to leave any debris behind in space, and we don't want to pollute our atmosphere or pollute our space. So that is the thing you need to keep in mind. Just any technology which you uses, you need to analyze what is the impact on our environment for that technology. And then protection and documentation of current progress is what we need to ensure because a lot of the lot of progress are there in space field which are not well documented. So documentation really important. So that I'll count as a challenge, because very few people understand that documentation, how difficult it is to like write some 100 pages of report based on a project. So that's why I've written down for like this, like challenge. So the need of the hour is research and development of new technology, and maybe technology fusion from other sectors. Like there are a lot of other sectors, like even aerospace, this aeroplane agencies and all, aeroplane sectors and all. From there we learn a lot of things. There are other sectors like this deep space submarine and all. From there we learn something, and we try to do technology fusion in order to produce something best of both the fields, space and maybe aeroplanes, for example. Say, we take aeroplane, then we combine both of them and we find some technology which is a really nice technology and which may be useful for future mission. And then other space agency are there, through them some transfer can happen. But this is very rare though. Anyway, so we should always try, and it's better to try and fail than never to try. So this completes like that what the challenges we are facing right now in this field. Now going to like emerging R&D. So first one is space exploration. As I mentioned earlier, we explored maybe less than 0.01% of the space. So our challenge is now to explore as much space as possible. So for that, we need different sensors, different telescopes, and all to understand so different solar systems and which planets might be having life, and which planets contain elements which might which might constitute a life, and which planets were formed when. To understand all these things, we need to explore. So left hand side, you can see this image is the first telescope which was launched into space by NASA. It's like OAO2, Orbital Astronomical Observatory, and the second one is very popular, Hubble telescope. So India has its own telescope as well. It was AstroSat. It was launched in 2015 by ISRO, and now it is out of operation because the lifespan was 5 years. So 2020, by 2020 it was done. We got some really interesting informations from AstroSat as well. So these all satellites actually help us to understand better what I said, like exploration part. They'll help you to explore space more, and they'll give you a good idea about what is going on and how do you about the possibility of different theories. So, and Hubble telescope actually is attributed to lot of discovery of lot of planets and lot of stars, as I know right now. Like it's like it's been really it has been really useful to NASA actually for all these discoveries and all. So if you want to go to deep space now, like you need some form of propulsion which is not conventional. Like thrusters, if you depend on regular thrusters and chemical propulsion systems, those have the power to take you to space, and probably they will take you to deep space also. But after some point of time, you just are void of all the chemicals. Your fuel is over, or your oxidizer is over. Something gets stuck somewhere, and you have to depend on solar panel or some other mechanism to kind of transfers to space, and that too, like the as far as you like when you get far away from the sun, your own sun, like the power gets reduced. The power generation gets reduced like maybe 5-10 times. So it is not that much like efficient. So nowadays, this ionic propulsion technology has come. So instead of using chemical gases and doing a combustion, you directly pass some ions and try to accelerate them, and you throw the ions into space. That way, you can carry less mass. Like you can just work with it will be equivalent of 10 kg of ions will be equivalent of like maybe 150 to 200 kg of chemical propellant. So it will be that good. And in space, as you know, there is very less resistance and there is very less friction, and you are not like going against the gravity. The gravity is there, but it is helping you to maintain an orbit, but you are not powering against gravity to do something. So there, this ionic propulsions, ionic thrusters and all, they generate around 25 millinewton to 200 millinewton of thrust, which is very less actually. You usually deal with like 2 Newton or sometimes 10 Newton or 20 Newton of thrusters in space. This is really less, really less. But in space, you're not fighting against gravity, so it doesn't. You don't require that much thrust to go ahead somewhere. This comes as a nice kind of propulsion system which you can use for deep space explorations and other missions like that. So okay, so this clip again, I mean the sound will not come, but I'll just show you the like first ionic flight. So this was without any ionic, without any propulsion. Just they gave some velocity, and it landed directly like because of projectile motion. And then second is with that ionic wind propulsion. You can see like literally it went around 5 times, 6 times the distance of what it went through that direct projectile motion. So this was developed. This was like demonstrated by MIT in 2019 or 2020 in that time frame. Uh, so they were first able to demonstrate this ionic wind propulsion. And nowadays, space agencies like ISRO and other even NASA and JAXA and all, they are trying to incorporate this ionic propulsion technique somehow to get some um, better propulsion system in future. We can use those propulsion system for traversing into deep space networks. Okay, so okay, so after I covered this ionic propulsion, I want to go into some different kind of emerging field which is being currently used. So this is reusable launch vehicles. So one on the right you can see that is reusable launch vehicle, testing that technology demonstration. Because of that, so that rocket was used for that, and you can see like it is a mixture of aircraft and rocket. Like the first part of the top part of the rocket is like aircraft, and the bottom part is like rocket. So you just try to launch the aircraft into space. Here in the left hand side, they've done the helicopter, but actually it will be like launched into space. And then once you are launching that into space, you just that fuel will burn. The bottom stage of the rocket, it will burn down and it will just disconnect from the top stage. And the top stage has got parachute in that, and it has got aerofoil kind of structure to get some lift, and it will depending, as you know, like the aerofoil structures, if you change the shape and all, you will generate drag from that. And so we are taking help of that, and with parachute we are able to land. So in future ISRO missions and all, there is a possibility of we using this also, because uh, as I said, we want to reduce space debris and we want to reduce space pollution. And this one reusable launch vehicle would cost around 200 to 250 crores of amount of money. So if you're able to utilize again and again one same type of launch vehicle, then we'll save a lot of money there. And funding constraint will be very handy there. Like this reusable launch vehicle will be handy in terms of funding, in terms of efficiency. It will save our time. So this is a really nice technology which ISRO is currently working on, and other I think many other space agencies have already worked on this reusable launch vehicles. Then the second thing is air breathing propulsion system. So usually what happens is whenever rocket get launched, they will carry their own fuel. They'll carry their own oxidizer. So as you know, like oxygen is important for combustion. So the oxidizer is a mixture of oxygen and some other elements. And like when this fuel and oxidizer are combined through combustion, then only like you will be able to throw out some that gases, and you will be able to propel forward. That oxygen we used to, like oxidizer we used to carry with us in our launch vehicle, but we wanted to do something different. We wanted to breathe the air from our atmosphere instead of carrying it ourselves. So that way we can save a lot on weight, we can save a lot in fuel, and we can carry more fuel. Instead of oxidizer carrying fuel and oxidizer both, we have now space for fuel. Both of the space will be utilized for fuel, and your oxidizer weight which was there, that will be reduced, and you will get you need to now lift off very less mass lift off is required for that. Like again the fuel consumption will be less, so you can travel more, it will be economical, it will be cheaper. So air breathing propulsion system is the one. So you can see on the this series of images, this is like ISRO's air breathing propulsion system demonstration. This was done with the scramjet engine. The scramjet engine was integrated with this advanced technology vehicle, ATV, and we're able to demonstrate this air breathing propulsion system for around, I think, 300 kilometers, something in 300 minutes, like that. We're able to do air breathing, and we're able to successfully use the launch vehicle, demonstrate the launch vehicle capabilities. So this can be really handy for the first stage of the launch vehicle, where you are using where the atmosphere is very dense. You can use up the atmosphere's oxygen and no need to carry oxygen on your own. So that being said, we are almost done with the launch vehicle part. Let me move to the satellite part. So the satellite usually, what I said earlier is like there is a lot of manpower involved in ground stations, and there is a lot of manpower expertise involved in satellite building and all. So whenever there is a launch, till the satellites become operational, a huge amount of manpower is required to monitor all those operations, and it is required to take some decisions, take some critical decisions and all. It's been in that process. The other projects, they get delayed. They will be stuck at some point. So you don't want to hold those projects. You want to take them with you want progress there also, and you want progress here also. So here, if we have this autonomy in space, that will really help us to tackle all this. Instead of we monitoring, instead of humans monitoring everything, space should the spacecraft should monitor its own health. It should tell us when it is danger zone, or when there is some critical issues going on. It should tell on its own, not we monitoring everything. So that way, autonomy in space is required. It should do everything on its own. And the left hand side, you see you can see it's a robotic arm. So this robotic arm is going and grabbing the satellite. That way it is being done autonomously. It knows where to go and how to capture. Um, Based on many techniques are there which can be employed to get this thing done. Then the right hand side is NVIDIA Jetson Nano GPU. So this is the first GPU and this is the first and only GPU which has flown to space. So right now this AI/ML is again a booming sector right now. AI/ML, a lot of things are done through AI/ML. So AI/ML models are usually data hungry. So they naturally they will require something which is able to process the data, which is able to train the model. Nowadays, we are able to fly the trained model in spacecraft, but we are not able to train the model on the spacecraft. The model cannot be trained on the spacecraft. It needs to be trained on ground. Then that you need to port it into some VLSI, some microprocessor somewhere, something, and then you need to put in the spacecraft. That cannot be trained on board, while it is flying. So this Jetson Nano actually is a GPU which consumes very less power, around 15 watts of power. So that GPU actually it helps in online training of the images. The spacecraft from the image can be the image from the spacecraft can be directly fed into the model, and it can be trained with using this GPU. Everything should be done on the satellite itself. No need to communicate it to ground, and again go take it back. That itself is a time-taking process, and it introduces a lot of delays and a lot of manual labor and all. So this is really important, this autonomy in space. So I'll show you another video in which I'll just go through very fast. You can see a robotic arm is approaching one satellite. Yeah, you can see how the robotic arm is trying to capture. It approaches slowly, and then it recognizes okay, I need to capture that circle thing with the dot, and then there is straight line. It is approaching that directly, and it will capture that. So everything is trained in like everything is programmed like that. Like it will be able to recognize this pattern. It will be able to go. It will be able to correct its pose and all. And then it will go straight ahead and capture it. Now it is captured. Okay. You can see now it is captured. This is like the Cygnus spacecraft, and it was being captured from that International Space Station. This is what is nowadays. It is like current technologies which is being developed by ISRO, and which is and like this technology we are trying to develop it, and we are trying to demonstrate this docking algorithms and all. So again, but I said like ground support is the left hand side image is from his track. Probably many of you might have seen this image. And during Chandrayaan 3, we had similar kind of live streaming. So, so here you can see a lot of scientists sitting and just monitoring those systems and what is happening in those systems. They want to know. They will take critical decision based on the operation of the spacecraft, based on the state of the spacecraft. And like I shown in right image also, like the spacecraft is very less, and the ground support it requires is like 90% of the total effort. So again, that is what we want to minimize. And also like there is a human error behind many. Human error is a major cause of failure of many missions. So we don't want to involve human in every routine decisions which you take. Human are prone to erroneous decisions, and they some may not be in right state of mind to take any decision. That is quite possible, and so that for that we want to bring some autonomy in space. Okay, and then going into a new emerging technology, it's called formation flying. So usually you might have seen formation flying in spacecrafts in Republic Day parades and all. Republic Day, Independence Day parade, they will fly the spacecraft, and they'll be in continuous formation. They'll fly some distance with the same formation, and they will change some formation in between. They will go into some different formation. So that is what we are trying to do with satellites. There are a couple of like there are large satellites, and as well there are small satellites which are getting involved in this formation flying. So the advantage of this formation flying is you can monitor an area. One satellite, you might know, it will take some time to go and revolve around the Earth. So when it is not at top of your head, or when the FOV of that satellite is not covering your area, that time all the satellite functions cease. They cannot properly function. They cannot function actually. They are not able to see you. They cannot function in the way they are designed to function. So at any point of time, whichever area the satellite is looking into, that area it can serve, like it can cater to that area's need according to the design of the satellite. But we want to this monitoring and the service to be available continuously every, like for the 24 hours, 24 into 7. We want service of the satellite. We want communication. We want ATM. We want GPS. We want like navigation in SIPs and all, like everything we want to be done continuously. So for that we need to either go for a constellation of satellites, or you can go for a formation flying. So constellation satellite is like GPS. GPS has like different 6 constellation of satellites. So every satellite is one orbit. So at any point of time, two satellites will all three satellites will the FOV of three satellites will always be on your area at any point of time. GPS is designed like that. So information like that refers to constellation satellite. Information flying basically maybe you can monitor defense regions like many satellites are there which fly in low Earth orbit. Low Earth orbit is in like 400 kilometers to 600 kilometers um, from the mean sea level. So when they're flying in 400 to 600 kilometers, they cannot cover very large area. They'll maybe cover maybe around 15 to 20 kilometers in your ground level. But for defense monitoring, you require some maybe 200 kilometers at once. You need to monitor that. For that, you can arrange like 5 6 satellites in formation, and you can monitor every satellite monitor 20-kilometer part, and all this can be combined, and you can gain the knowledge of 100 kilometers directly. So that is how the formation flying works here. Again, I have one more video. I'll show you. This is a actually frictionless table kind of thing. So usually your satellite is in like it can move in 6 degree. It can move in 3 rotations and 3 translation X, Y, Z, and your own pitch motion. But this table, this 6 degree of freedom is very difficult to realize in like Earth, because we don't have in lab, especially it is not possible to achieve 6 degree of freedom directly. There might be some constraint like robotic arms. Will have 6 degree of freedom, but you will have some constraint of like length and all. So if you want to remove those constraints, they usually will test with this 3 degree of freedom platform. So this 3 degree of freedom platform like is frictionless. The the plane on which the satellites are moving is frictionless. So there is 2 degree in that plane and rotation 1 degree, so total 3 degree. And the satellite can move here and there, but the only thing is it is restricted on the like the top and bottom jet movement. That way you can just see how just get an idea of how it is moving to some extent. So in this, you can see like these three satellites are there. They're communicating with each other, and where their position is. So what the user does is it commands them. You don't rotate like as per you want. Just rotate in a circle. So you can see like here they will be rotating in a circle like this. So that is called formation flying. They communicate with each other. They will decide their position based on that communication. So you can see how they're rotating in a circle. Okay, so moving again to nanosats. So what I said earlier that there are many small satellites and large satellites involved in formation flying. Uh, Typically nowadays, like all the space agencies, they try to go for small satellites while going for formation flying. The advantage is like whenever you are doing a formation flying, you need like tens of or hundreds of those satellites in a formation, and if you involve large satellite in that, your cost will like increase like anything. It will exponentially increase. So this small satellites like nanosats and like the left hand side image I'm having, that is picosat. So the picosat cost is typically maybe less than 1 to 2 lakhs, or at max it will be like 10 lakhs, depending on the what kind of electronics you're using in that. So if you have tens of satellites with everything having 10 lakhs budget, then you are max to max you are going for 100 lakhs or 1 crore. So your whole project is complete within 1 crore budget. But it's the same thing if you're going for large satellite, maybe two of large satellite, it will cost you maybe somewhere near 500 600 crore. So 600 times it is this cost is reduced. So typically they will go for small satellites only. The left one, I said picosat, so it is like you can see how small it is. Like it is size of my hand, some 8 centimeter maybe at max. And the right hand side is nanosat. There are actually currently lot of universities are there which are working in nanosat. Like one of them is like IIST, where I did my bachelor's, and then second thing is IIT Kanpur. And there are also a lot of private agencies like Dhruva Aerospace and Skyroot or Bellatrix. I'm confused. So they are also like uh, going ahead in this nanosats and like producing this nanosats and picosats and flying them and serving some purpose. So this typically they will use these nanosats for monitoring Earth observations, or like maybe forest fire monitoring, or maybe this soil monitoring, maybe water monitoring, or like weather forecasting. These are things they will use this nanosats and picosats for. Okay, moving on to next type of missions like sample return missions. As you know, like Chandrayaan 3 landed, but it didn't collect any sample, and it didn't bring any sample to Earth. It had in situ experiments, which means like the experiments were done wherever the Chandrayaan 3 lander landed. There only the all like most of the experiments were there, done there only. So in future, like as you know, like the satellite has very has got a power constraint. It has got a budget constraint. It has got a space constraint. So we cannot fit like large instruments or large analyzing tools in the satellite directly. So if you want to analyze something more, you need to return with some sample, which our scientists here they can feed into some good analyzer machines, and it fit into some good really good like experimental setups. They can put it in that, and then they can analyze how it is. What is the purpose of the depending on the purpose of the project, they can analyze like the results, and they can analyze the samples and do everything in that. So that sample return mission is really essential for us now, because we want to know, we want to study the characteristics of different planets. Mars, say Moon, say Jupiter, Titan, anything. Jupiter is anyway, it's a gaseous planet, so I would say like gas sample collection. Um, say Venus or anything. It might be any type of sample return. So that if you want to collect any sample from anywhere, you need to have the capabilities of going and landing there, and then um, propelling against gravity and coming back to Earth. So this has been already been demonstrated by NASA. I think Apollo 11 was the first mission which collected sample from the moon. It was like back in 1969. So when ISRO started, actually NASA was able to do this, and so it started back then, and now it is like there is a lot of sample returns from um, asteroids, from comets, from Mars. There is no sample return mission yet. I think Moon, a lot of missions have been successfully carried out. So this is a new challenge for ISRO. Actually, we have now this upcoming Chandrayaan 4 mission, like plans to like handle this challenge. And then there is right inside it's a image of Curiosity rovers. So I think 2027 or 2028, ESA and NASA are planning to take like get some sample return from Mars to Earth. And then China also is planning, I think 2031, Tianwen 3, I think they are planning to do that. So that is like that will be like first of the mission where your orbit is kind of interplanetary, and you're able to return that sample from that Mars to Earth. So it will be a really difficult challenge. So okay, then moving on to space mining. As I said, like you have sample return missions from comets, from asteroids. So I think Japan has successfully demonstrated twice asteroid mining demonstrated. So the purpose of that was like for to solve the um, later on, like in future needs, you might be we as humans might be exploiting the earth and might consume every minerals or every what the kind of but how do I put it? Like is like we have a lot. We are using a mineral at a rate that we might just deplete it at some point of maybe it's in 50, 100 years we might deplete it. So this point of this asteroid mining is like we want to explore other asteroids. We want to see whether we are able to extract some good minerals from asteroid, and we are able to use it for our purpose. Although I would say it is very selfish to go and ruin asteroid for our needs. Better to control our own needs and try to become like self-sufficient and not depend on asteroid. But still, I mean, it is on progress. Then Japan's Hayabusa 1 and Hayabusa 2, I think Hayabusa and Hayabusa 2, and I think recently NASA's Osiris Rex, I think it returned with a sample from an asteroid around October 2020, September, October 2023. It returned with that. So this is a really, I mean, emerging field right now. I'd not say nice. It is selfish actually, but it's also a direction of approach to go and mine the asteroid and come back. And there are a lot of elements in our space actually. You might be knowing like hydrogen is the most um, common element in space, and after that helium is there. So it constitutes around roughly 75% of roughly from that figure. You can see hydrogen constitutes 70%. So hydrogen, as you know, is a fuel and it can serve as a green fuel. From that, the like the outputs, it's not output actually. The products are water and heat. So water is a clean gas. So hydrogen is a really nice clean fuel, and like the space constitute of 78% hydrogen. That means we can extract hydrogen from space, and then helium also is like some maybe 22%. That also you can extract from space, and there are a lot of other minerals also which are of importance for us, like in say oxygen and carbon. Those are like the life forming elements. So the occurrence of that in space is a proof that we might be like is a part of the theory that we might be originating from space. That is how those are relevant, and we can use that for our purposes. Then 3D printing for space components. Actually, so this 3D printing is really nice in a way that we are able to the thrusters and all the actuators and everything. Those are everything is like man-made, and everything is like not exactly man-made. I would say like they are developed meticulously by hundreds of workers who will work in shift day or night to develop some products like that. It's not yet developed into something like an assembly line, like you design a car or like you manufacture a car. You have an assembly line in some part gets automatically fitted into the car, and your car is ready after maybe some half an hour or 1 hour. Your car is ready after that. So that part is missing in space like technology right now, because every technology has its own need. However, some parts like thrusters and all, it can be automated. The manufacturing process can be sped, like we can speed up the manufacturing process using this 3D printing. Till now, it is in a nascent stage. It's not yet like developed into a mature stage, but work is going on to have this things 3D printed. Right hand side, you can see like there is a space this launch vehicle which is printed with a 3D printer, and I don't know whether it was able to like fly or not, but this is how kind of print the launch vehicle. Okay, so ongoing efforts in ISRO, as I said, space stations. I think our Prime Minister Narendra Modi, he announced that Bharatiya Antariksh Station is going to be like launched by 2028. The space station serves as like a space port kind of thing. Like your satellites will go to space, they will dock at space station, and they will again like get themselves refueled there, or some it might be a crewed mission. The astronaut will get some refreshment in space station. They will go for the somewhere else. It kind of serves as your hotel or some resting point. So that is what is being currently ongoing, and that is a challenge for us as well. Like we need to dock everything. We need to it cannot be launched at once directly. It needs to be launched in parts. So everything needs to be assembled. Everything needs to be put in place. Then humans in space, as you might recognize, the left hand side is like she is Vyom Mitra. She is the humanoid currently in Bangalore only, HSFC. And then right hand side astronauts, they are also in Bangalore right now. Anyway, this I would rather call them Vyomnauts, as the term is. So we are on a process of making the spacecraft environment habitable for these biome nerds to survive there and safely go and return back to Earth. And is for our testing purpose, we'll be using Biomitra to understand what kind of problems the biome nerds might face in the Gaganyaan missions and all. Space warfare, as I covered, the right hand side is you can see like the space army. I think space army is they call US Space Force by US, and then debris, as I covered, like there are a lot of anti-missile tests going on, and they leave a lot of tiny bits in our space. You can see like 1957, the Earth was so clean. There was no satellite, no debris. By 2005, it has become I don't know, some seed kind of thing. It has become like that. So it's the debris is really growing up in number, and by 2018, you can see how dense it has become, and by 2030, I don't know where we are going. So it's very important to control pollution as well. This is also our job. This also we need to take care of our environment. So as you know, like around 96 bags of waste is there on Moon, and maybe around 5 lakh ton or something waste is there in space. So all the astronauts who have landed on Moon have left around 1969, that time, 10 years of that. They've left a lot of waste material on the Moon, so it's kind of polluting the soil of the Moon. So role of public. So this is where you can see right hand side our ex-chairman K. Sivan sir and Prime Minister Narendra Modi ji. So this is after Chandrayaan 2 failure, and so public actually is really helpful in these things, like putting emotional and mental support for ISRO scientists and all, and we're really thankful for support to them for supporting us. And then public also is now they're leaning towards made in India products. Like I think some mobile was launched with Navic rather than GPS. So that is a moment of pride for ISRO, and as well as for India, because GPS is something which is developed by NASA, and Navix developed by ISRO. If you're using made in India product, you are contributing in country's growth. And then collaboration with ISRO, and then technology transfer or sharing for new missions, like I discussed earlier. Like there are a lot of other fields from where the technology is fused to get something else. Like I showed in this thing also, launch vehicle, reusable launch vehicle too. Reusable launch vehicles I showed like how the aircraft and missiles and technologies combined together to get something new. Then space awareness and enthusiasm. This really boosts up our morale, because whenever public is like shows enthusiasm about space. Then how do you help us? How do you help in progress? So you can go to this website is Respond Basket. So there we have a lot of projects which are made public, and there we provide the funding, and like many organization and many institutions, they will respond with their solution. We have a problem statement, they'll respond with their solution. We will have a discussion within ourselves, and we'll select whichever gives us the best result, or whichever they feel is will be able to give us better result. And then we give funding to them, and then they develop something, and they will reply us back. The collaboration is like both way it is happening. Like in ISRO Respond, only we are giving you the problem, we are getting the answer from you. In collaboration, we are collaborating together to get some answer. Then internship, our project at ISRO for students, final year or third year students, BTech, maybe BC third year also is there. And so you can see like the first site is for URSC, where I am currently working. So there you can apply in this site, and you can just go ahead, and after maybe 2-3 months you will get to know whether you are eligible or whether your application is success, or like it was rejected. And then there is one more site, ISRO, where you have all the other labs also, all the other lab like SCL, not SCL, yes, SSC and VSSC and Sriharikota Shar and then NRSC Hyderabad. And there's other labs are there, so there also you can do internship or project through this site. And then there are JRF also in ISRO lab. You can just directly like go and apply it in any of the centers. If there is something which is vacant, JRF fellow, you might get. Then also, it will be really helpful if you use publicly available ISRO data in your projects and all. Like uh, those will we have collected the data for our needs as well as for the country's needs as well. Like we want researchers to use our data and to come with something meaningful. Then lastly, you should join ISRO. So for joining ISRO, there are two methods actually. So one is ICRB and other is campus placement. Um, so earlier there used to be a third method also from IST, but now it is stopped. So if we are joining through ICRB, then it takes approximately 1 to 1.5 years, and you appear for an exam and interview. And this process is very organized, and the candidates having bachelor degree or higher, like you should have at least a bachelor degree, and you should have completed a degree. Then you can apply for ICRB. A lot of posts coming up recently. I put the link. You can just go and see there. And then campus placement, it is generally through ISRO directly. Like ISRO higher ups, they will decide which college they want to go to, and they will select like whoever is whoever wants to come join, and they can join. But it is available at very few colleges, like IITs. It's not available in every college. So and it depends on ISRO administration higher ups. So this is my contact detail, my personal email and my official email. I would rather prefer you contact me in personal email, official for maybe some official work you can contact. And it's my LinkedIn profile. Okay, thank you everyone, and thank you for listening to me patiently. I hope everyone like enjoyed the slides, and I was able to cater to your interest. And thank you Temstick for this opportunity. And I would like, if any questions are there, I'd like you to come up with that.
Yeah, thank you, sir. Thank you for the presentation. And I have some questions here. Okay, so participant somebody asking questions. Devanshi Verma asking what possible projects one can undertake being in the EC branch in the first year itself.
Sorry, what possible projects can we?
What possible projects one can undertake being in the EC branch in the first year itself?
Oh, okay. I assume this is related to space. So, in EC branch BTech first year, I would advise that maybe you can get a hold of control systems or coding skills is really necessary. Like project, it will require a all-round knowledge of different subsystems. So unless and until subsystem knowledge is there, better to go on and develop those knowledge like the control systems maybe, or maybe through coding like OBC, like onboard computer coding and all, ADA coding or C++ coding. Um, that's it. Like other parts, it will gradually come. So I would request you to wait till you understand those things and then apply.
Yeah, okay. Thank you, sir. Sir, another one question from Mukesh Muthuraman. I'm studying in aerospace engineering. How to join ISRO in future?
So I already I think shared joining at ISRO. So there are two ways to join. One is ICRB, another is campus placement. So ICRB is actually the most common way to join ISRO. So there you have to appear. You just appear, register yourself in that according to the post. Appear for exam, appear for interview, and if you're selected, you'll join ISRO.
Yeah, okay. So another one from Nikita. I'm studying aeronautical engineering third year. Can you tell me how to apply for DRDO for internships?
How to apply for?
Internships.
Achha, internship. Okay, internship.
DRDO.
Okay, so where I am working is like in URSC. So there I have shared this link. You can go to Students Endeavor. Like there is a site called Student Endeavor in ursc.gov.in. You can go there and you can apply. Um, I think for now it is stopped till May. I think from May 1 again you can apply for the upcoming winter internship like December or summer. I'm not sure. December, like this 2024 December internship, you can apply from that time. There is another way to do internship also. You can just directly put a letter from your HOD and your department, and you can send it to our HRDD here in URSC, and they will respond to you. They'll get back to you.
Yeah, okay, thank you, sir. So, okay, I have some questions from my side. How will advancements in artificial intelligence and machine learning enhance the autonomy of spacecraft and rovers for the deep space exploration?
Okay. So as you see, like whatever functions we are trying to achieve through spacecrafts, those are like manually designed. Like for example, say I'm taking the example of docking. Docking requires two satellites to be joined. They need to combine in space somewhere. For example, like Bharatiya Antriksh Station, for that you need to separately launch 3-4 parts of that BAS, and then you want to join them together in space. So when you want to join them together in space, you need to know that I am joining with the right object. Like it shouldn't happen that you are joining with something else. You need to have a brain kind of thing. Like you need to go and you need to see where I have to join. You need to go approach it slowly, and then you have to take a grasp of that part which you want to like grasp. Like you cannot grasp a random solar panel of the satellite. It will break the solar panel. You cannot grasp thruster of the satellite. It will break the thruster. You need to grasp its specific part. For that, you need to identify that part. For that, you need brain. Like the satellite needs to have a thinking mechanism of its own. So that's where AIML comes into this picture. So the AIML will do the thinking, and you just go and satellite goes and do the maneuver because of that.
Yeah, okay. So,
Am,
thank you,
am
sir.
I-
Another one student from Neena Hamsa asking internship in DRDL.
can you repeat, ma'am?
So, Meena Hamsa asking internship is available on DRDL.
D or DL is in? I'm not able to understand. What is DL? uh, the like what I said, like internship is available directly. I'm not understanding the question exactly at DL or D. So maybe can further a little bit explain.
Yeah, okay.
So anyway, I'll repeat my point. As an internship, there are two sites for applying. Just go there and you apply. This is like ISRO internship is non-paying internship. You don't get any money for your internship or any project you do there. However, the work is really interesting. I would suggest you all come and you just experience ISRO once.
Yeah, okay, sir. This is my final question. So, what developments are expected in space propulsion technologies that could significantly reduce the travel time to Mars and beyond?
Um, so, I mean, for now we are using chemical-based thrusters only, Mongolian MOM1 also. But we want to go ahead with some different kind of technology. I've shared already, like reusable launch vehicles and ionic propulsions and all. Like for the part of from Mars, from Earth's atmosphere till Mars atmosphere, that part is like in space, deep space. There you are not facing gravity like challenges. You are not going against gravity. There, definitely you should opt for ionic propulsion. However, the process is like it's not very easy. we are on that ionic propulsion. We are developing that, and we are working that on that current constantly. So it might take some years to realize that. I hope that we'll be able to realize by the next Mars mission. That is how it will help in propulsion. That is how we get propulsion system for Earth to Mars. Nowadays only thrusters are used. Thrusters and only on thruster, and based on that orbital transfers, we are able to go to Mars.
Yeah, okay. So thank you, sir. So your answers are very useful. I hope the access and the participants can understand about that.
I hope so too. The participant, I hope I was able to answer all your questions. Please reach out to me if you have any specific doubts. I already shared my contact details, I think.
Yeah, okay.
I think I took 10-15 minutes extra time. Really sorry for that,
Yeah,
actually.
it's okay. No problem, sir. I have some this network issue here.
Okay.
Yeah, okay. Sorry, sir. Sorry for the delay. I have some network issue here.
Okay, no issues, no problems.
Yeah, okay. So on behalf of everyone and attending the today's session on emerging technology in the space sector, I extend our heartfelt gratitude to Mr. Asish Kumar Mishra for his invaluable contributions and insights. Mr. Mishra, your expertise and dedication to advancing space, science, and technology have not only enlightened us, but have also inspired a deeper appreciation for the challenges and opportunities that lie ahead in the space exploration. And your work at the URI Satellite Center under the Indian Space Research Organization exemplifies the spirit of the innovation and collaboration that drives humanity quest to explore the unknown. So your achievements from pioneering the research in satellite technology to your hands-on involvement in missions like Chandrayaan 3 and Aditya L1 and reflect a commitment to excellence and passion for pursuing the boundaries of what is possible. So thank you and MGR Education and Research Institute for this wonderful collaboration, and thank you Vasanthi ma'am for this your coordination, and thank you Dr. Mr. Mishra for your significant contributions to the field of space science and engineering, and for being guiding light to aspiring the scientists and engineers around the world. So thank you, sir. Thank you so much for the session. Thank you.
Thank you.
Yeah, thank you.